So folks, this is activity DD90, and it is with creating this mechanism, which is called ellipse generating mechanism. Basically, it's these two blocks which are traversing along these two paths, and the tip of this rod is going to traverse an ellipse. In the event that this point, this block, is exactly halfway between the right block and the tip, then it's going to be a circle, otherwise it's going to be an ellipse. There are no dimensions involved here, so I'm going to make my own dimensions. Therefore, there's no reason to look at that. I'm going to maximize this thing. We are in the assembly design, so immediately I'm going to save this thing. So file, save management, save as. I have a folder here. This is the right activity. I just put it in there. Anything that I do with this problem is going to go into that folder. Okay, let's insert our first part. Insert new part, and it's going to be the base. So let me rename this thing to be base. Please make sure that you do these things properly for the sake of the midterm and the final exam. You don't want things to overwrite each other. So double click on the base and I'm going to, on the horizontal plane, I will sketch a square, something that is almost a square. So like that, this is going to be the pathway is going to be on this space. So exit. Why don't I pad this thing by 10 millimeters? Okay. And then on that plane, I'm going to sketch because I want to draw those, carve out those slots out of that. So I'm going to make something like this. Okay, let me put some dimensions here. So for example, just for my own benefit, from this point to this line to that line, I'll make it 5 millimeter. 5. Okay. And the width of this, I'll make it also 5. Right, exit. Now I'm going to make a pocket all the way through. So here's a pocket to the last. So there is one of the pathways. Now I want exactly the same thing perpendicular to that. And obviously you can go and make it again, just like I did here, or you can use a circular pattern. And what I'm going to do is instances, two of them, an angular spacing 90 degrees apart. Okay, the reference element is the z-axis. It's going to be patterned about the z-axis. Right click z-axis, and the thing that I want to pattern actually is not the whole solid, but it's just that pocket. There we are. We change the rendering here so that we don't see all the unnecessary lines. Ooh, okay, so this one, I should make it all the way to the, well, let me make this thing a little bit smaller. This base a little bit smaller so that this pocket goes all the way through. For example, I go here. I'm not sure which one it is, but maybe that should do it. Exit. Yeah. Okay. So all the way to the top. Save everything. Good. And then I'm going to insert one of these blocks. I think this is still not going all the way to the end. I did not realize that. Okay, let's make it a little bit smaller. Or you can make the pad, the pocket longer, either way. Since dimensions are not important here, we can do whatever we want. All right, so all the way to the top, click on the floppy so that everything is saved. And then insert new part, and that new part is going to be one of those blocks. So I'm going to say no, as in the past, right click here, properties, change it to block and block. Now remember, the two blocks are identical, so I don't have to make both of them. I can make one of them and then insert the existing component. Or if you don't want to do that, go and make another block. So double click on it. Okay, so on that plane, just so that I can see the sizes. Remember, this was 0.5, the width was 0.5, and the height, I'm going to make it 10. Okay, so really doesn't matter where you do it. So on that horizontal plane, I will sketch. Okay. So a square or a rectangle, doesn't matter. The width of it for visual, pleasing visual purposes, I'm going to make it 5. Okay, the width, this is the width of it, so it fits not snugly right there. The length of it doesn't matter. And because I want to make a hole there, so that the arm can be inserted in, I'm going to make a hole like that. And let me see what this dimension is, or I can dimension it. Actually, I'll make it 2. I'll make it 2. Okay. Exit. Actually, did I make diameter 2? Let me make diameter 4. Let's go back here. Diameter, yeah, I'll make it 4. Okay, good. Exit. And then we pad it. Pad it by 10 millimeter. So this is going to go into that hole. Okay. All right, good. All the way to the top. Click on the floppy. So it's going to save this. And then I'm going to say insert existing component. And that is the block, right? Okay. They're sitting on top of each other. You can separate them using the move icon. You move transit in X, for example, you can see that they're sitting on top of each other. Good. Now, let's go and make the rod. Okay. All right. So all the way to the top, insert existing new part. No, I always say no. Right click properties, rod, or I'll call it yeah, rod or arm, or I'll call it rod. Rod and rod. Okay, let's go make it. Now, because I'm kind of lazy here, here's what I'm going to do. On that, to draw this thing, I'm going to draw it actually on that face. Okay, sketch. All right, and I'm going to project both of these circles. Where's that project? This circle and that circle. I think you have to do maybe could have probably done it at the same time. It really doesn't matter. Okay. And then I make the rest of the rod. So I don't want to make it very fancy, so I'll just make a rectangle like that. So the rod is going to look like this, okay? And notice that if I hide that, everything is going to be in place, and I can do a multipad. If I want to turn these things into pins instead of hole, then I do multipad. So exit, multipad. As far as mechanism concerns, doesn't matter whether they're holes or they're actually pin, but it looks nicer if I make it a pin. So this is going to be the whole periphery. I'll make that thing maybe 3 millimeter. This one is going to be more than 5, so I'll make it 6 millimeters. So 3 millimeters are going to be the height of that rod, and 3 millimeter sticking out. Okay. You can see that. Actually, to make it see better, maybe I'll make it 10. How about that? There, you can see it now. Probably. We'll see. We'll see that. This one is also 10. 10. And then you say, okay, right there. Okay, and you remember the other guys are in hiding, so let's go get them. The other guys are in hiding. Let me show this and show that. Okay, let's go back to the front zone. All right, so we're going to go and do the assembly all the way to the top, and all the way to the top, and save it. Okay, let's separate these things. So let me translate this thing in the y direction, the x direction, sorry, y direction. Yeah. The first thing we're going to do is to anchor the base. So here's the anchor. Okay. Then I'm going to bring this thing and put it in that slot. So coincidence between this edge and that edge, and coincidence between the side plane and that side plane, or the bottom plane and bottom plane, and update. Okay, good. Now, if I drag this thing, translate in the y direction, this one is going to be in that slot. And I do exactly the same thing on that other slot. So coincidence between, for example, this edge and that edge, and coincidence between this plane and that plane, update. There we are. And now we're going to insert these things into those holes. So coincidence between this axis and that axis, and coincidence between this axis and that axis. And one of them needs to be plane to plane. So coincidence between this plane and that plane. You don't have to do the other one. If you do it, they're both going to become revolute join, and there's nothing wrong with it. If you update and doesn't look good, then we flip the arrows. You can see that. You can see already that it doesn't look good. So let me go ahead to that constraint. The very last one, flip the arrows, okay, and update. That looks a lot more respectable. All right. So, first of all, let's go and save everything. And then we're going to try to move these things, see if assembly constraints are actually correct. So here's the move and manipulate. Make sure you check this box. And let's rotate about that, for example, uh, rotate about this line. Okay, let's try it. We drag this and we see that. So at least on surface looks good. Good. Okay, so we're going to save everything. Now we're going to go to digital mockup. Uh, Digital mockup DMU kinematics. Get the magic wand out. New mechanism, mechanism number one, auto create. Okay. So what's going to happen? There's going to be two prismatic joint. Oh, by the way, notice that the width of this, the width of this, I was supposed to, I wanted to make it the same as the width of that. This was 5 millimeters. Remember that? I forgot to do it when I did. Yeah, when I made the box, I probably did not make that 5 millimeter. But that's okay. As a mechanism is concerned, it really doesn't matter. We'll just leave it the way it is. It's just bad, bad cartooning, but it's okay. Just leave it the way it is. Okay, so there's going to be a revolute, a cylindrical, and two prismatic. Let's check it out. Prismatic, cylindrical revolute. Please don't let this interference bother you. Try not to do something like that on the test. Make sure that everything works the way they are. All I have to do is to make the size smaller, okay? And it'll do the job, or make that width larger for visual purposes. Okay, so how do we make this thing degree of freedom 0? We can go to that revolute joint, or we can go to a cylindrical one too. Make it angle driven 0 to 360. What did I do here? 0 to 360. Good. Mechanism can be simulated. Can we do that with command? Click on the simulation with command. You can see that there. All right. Now, since I want to get the trace of that, I will have to create a simulation first. You click on the simulation icon here in the DMU generic animation. Select that. Okay, drag this thing all the way to the end. Insert anything but one. Rewind it. and you can actually see whether it's working right or not. So it is working. Okay, so good. Stop it, send it back to where it is, reset it, we say okay. Now, a simulation has been created here. You can see that. Now, what we want to do is to find the trace of this simulation. So in order to do that, trace of this mechanism, or trace of that point. So what you need to compile it, you click on it. In order to get the trace, all you have to do is generate a replay. Just make sure this is not 1, for example, 0.2, and then you say okay. Good. So replay has been created. You can always play the replay if you want. And in fact, when it comes to marking your test, what I do is first I check a replay to see whether it's doing what it's supposed to instead of fooling around with these things. And now, once you create a replay, you're going to say right here, trace. Remember, if you use product, it's going to create a trace as a part. You have to save it in that folder and then submit it as a part of your submission for the midterm or final. Okay. But if I select, instead of reference product, select the base, notice that it jumped from new part to reference product. I don't have to do that. And the point that I want to find trace of, element to trace out, is, for example, this tip or any other point that you can create there. And then we say, okay, and there we are. You see? So when you when you replay at a low speed, you can see that that point goes through that ellipse. Okay, now here's an ellipse. Now, this is uh, basically it's just a cartoon. There is no physics into it. But what I can do, for example, is I can go and suppose that this uh, angle-driven joint was made to move by by electric motor. Okay, then you go and specify, for example, the angular speed of that motor, and by very similar to the activity that we did with the revolving arm, and then you can plot the velocity, acceleration, etc. I'm not going to do that for this particular activity, but please make sure you know how to do these things, because we have done it and we're going to be doing it more, and you will be asked to do stuff like that beyond just making a cartoon uh, in on the test. Okay. Now, before I go any further, let me close this. Let me save it. But I want to make another replay. I want to create another, compile something else, compile another one, compile simulation. Notice that this time I'm going to say, okay, don't generate a replay. I want an animation file. And this is the code. So where do I want to put it? I'm going to put it in that same folder. That's in the same folder. My first video. Here's the name. My first video. Say okay. And don't use one, use anything but one. Play it. Now, if you go to that folder that I created here, let's see if we can find it. It was these activities, and I think it was this one. There's the video, my first video. That was fast. There. Okay, so you can put it's an AVI file. You can convert it to I don't know, MP4, MP3, whatever you got. So that takes care of this activity, and we're good.